The answer to question 1. What is the equation linking energy, power and time? Well, energy equals power multiplied by the time taken. So if we put that into an equation for question 2, power and time need to multiply together. So power and time can go there and energy goes at the top. The units, well, energy is always measured in joules. Sometimes you might have work done instead of energy, but both of them are the same and measured in joules. Watt is the unit of power, so watts, and time is always measured in its base unit of seconds. There is the occasion when it's kilowatt hours, and that's when we talk about energy in the home and energy bills, but generally speaking these are the units. Occasionally though, kilowatt hours, kilowatts and hours, but that is an aside, although it's going to be useful for the end of this worksheet. Question 4, well, same when we've got a kilometre, when there's 1,000 metres in a kilometre, here we've got 1 kilowatt, so we've got 1,000 watts in 1 kilowatt. So 5 kilowatts would be 5,000 watts. And then just a bit of knowledge, how many seconds are there in 1 minute? Well, 60. In 4 minutes, that's 60 multiplied by 4. So that's 240 seconds. And then for 1 hour 35, well, we need to know how many minutes that is. So there's 60 minutes in 1 hour. So we add that to the 35. So that's 95 minutes. So 95 minutes times 60 seconds is 5,700 seconds. For question 6, how many watts in 3.4 kilowatts? Well, earlier we said in 1 kilowatt there's 1,000 watts. So in 3.4 kilowatts we multiply that by 3.4, so that's 3,400 watts. Calculate the energy used to boil a kettle with a power rating of 2,000 watts that takes 120 seconds. So we highlight the key things. So we know power equals 2,000. We know that if it takes 120 seconds, that must be time. And we want to find the energy. So we refer to our equation or our triangle. So energy, power and time. So we cover up energy to see that it equals power multiplied by time. So that's then 2,000 multiplied by 120, which gives us 240,000. The unit, of course, is joules. For question 8, calculate the power of a hairdryer that used 1.5 million joules of energy in 600 seconds. So again, we've got energy. Now the trick here, of course, is to make sure that you've got the right number of zeros when you put it into the calculator. We know the time is 600. We want to find the power. So again, we look for our relevant equation, and we see that if we cover up power, that gives us energy divided by time. So the energy, 1.5 million divided by 600 gives us 2,500 watts. For question 9, calculate the energy used when an appliance has a power rating of 0.6 kilowatts and is left on for 100 seconds. So the first thing to notice is our unit, 0.6 kilowatts. So 1 kilowatt is 1,000 watts, so we've got less than that. So 0.6 kilowatts is 600 watts. So that's our power. We know our time because it tells us it's 100 seconds. We want to find energy. So again, we refer back to our triangle, which gives us power multiplied by time. So in this case, energy is 600 times 100 . 60,000 joules. For number 10, a battery has stored 15.5 kilojoules of energy and lasts 2 hours before it goes flat. What is the power rating? So, again, we need to do a conversion. So 15.5 kilojoules is 15.5 times 1,000. And then time, we've got it in hours, but we would like that in seconds. So we know there's 60 seconds in 1 minute. We know there's 60 minutes in 1 hour, but we've got 2 of them. So the number of seconds, if you put it into a calculator or do it in your head, is 7,200 seconds. We want to find the power rating. So again, we go back to our equation, and we know power is energy divided by time. So 15,500 divided by 7,200. Use a calculator and you get quite a long number. So we can round that to 2.15 watts. Calculate the time to the nearest minute that the lawnmower was on for. It used 1,100 kilojoules of energy and has a power rating of 1.7 kilowatts. So again, we want to make things simple. So energy is 1100, but we need to multiply by 1,000 because it's kilojoules. And the power is 1.7 kilowatts. So again, we need to multiply that by 1,000. We can then find the time, but again, we need to maybe look at our equation again. And we know that time is energy over power. So energy over power. So that's 1.1 million divided by 1,700, which gives us 647 seconds. But the question wants it to the nearest minute, so we can divide that through by 60 because there's 60 seconds in a minute, which gives us 10.8 minutes, or to the nearest minute, we would round that up to 11 minutes. For question 12, calculate the power in kilowatts when an appliance uses 1 megajoule in 2.5 minutes. Well, the first thing to remember is a megajoule stands for million. So energy equals 1 million joules, and the time is 2.5, but then 60 seconds in 1 minute. So that works out at 150 seconds. We want the power, so again we can look at our equation. So power is energy divided by time. So 1 million divided by 150 gives us 6,666.7 watts. Now we want that to be given as kilowatts, so we need to divide that through by 1,000. So we could say 6.7 kilowatts. For question 13, I said right at the start we might occasionally need to use kilowatt hour as a unit of energy. So we need to recognise what a kilowatt hour is. Well, energy is power multiplied by time, but rather than power in watts, we would say 1,000 watts is the same as 1 kilowatt. And then rather than seconds, well, the number of seconds in 1 hour is 60 seconds in a minute, 60 minutes in 1 hour. So the amount of energy in joules that 1 kilowatt hour is 3.6 million joules. And for question 14, finally, why are electricity bills at home priced using kilowatt hours rather than joules? Well, on your electricity bill, if you end up using a lot of energy, which of course you would as a house, then given 1 kilowatt hour is worth 3.6 million joules, the number very quickly will get very big. So they use kilowatt hours just because the final value is shorter. So rather than the number on your bill being a massive long number, it's shortened and, well, ideally simplified, although many people do not understand their electricity bill.